Hello there. Today I'll be talking about the Moivre's theorem and the root of complex numbers. So for these two topics, you only have to use the polar form of complex numbers, which is z equals to r multiplied by cosine theta plus I sine theta. So let's start off with the Moivre's theorem. What is the Moivre's theorem? It's a theory regarding the powering up of your complex numbers. So it's like getting a super mushroom in Super Mario. So let's say you want to power up your complex number z to become, let's say, power of 3. So you'll write down 3 here and here, right? But how do you cube this bracket here? Well, according to the Moivre's theorem, you can do so by multiplying your angle with your degree of power. In this case, it is 3. So you do so like that. if what you're powering up with is not the same complex number, then you multiply the two angles together. So let's say theta right now is 2, and your other complex number is 3, so you multiply them together. And next is the root of complex numbers. So root is quite similar to the De Moivre's theorem, except it's going the other direction. So it's like a Minecraft slime, then you kill it, it becomes smaller. So we have your z. You want the root, let's say, become a cube root, 1 over 3. I'll write it in the index form like this. So r will be 1 over 3, and this whole bracket will also be 1 over 3. So this part, the next step is slightly different to the Moivre's theorem, because instead of just having theta divided by 3, you'll need to add on a special part, which is 2k pi. Then only you divide it by 3. Now, let me explain why. This is because you have your complex number, let's say it's in the 4th quadrant. Let me draw that out as an example. You have your complex number in the 4th quadrant here. And if you want to find your theta, then it will be from this part going all the way to the 1st quadrant like that. Yes? Now, this 2k pi ensures that your root stays in the same quadrant, which is the 4th one. So this will be the first root, and your second root, I'll name this as theta 0. And your second root will be going one round like that, and then another round touching the 1st quadrant again. This big spiral will be theta 1. So k starts from 0. That's why this is theta 0. And so this is the first root. And your second root will be k equals to 1. So it will be theta plus 2 pi over 3. And you'll get is theta 1. And this is your second root. Your k value is always smaller by 1 of the root value, which is 3 right here. So right now, since I'm finding the cube root, so the maximum value of k will be 2. So I'll have k equals to 0, 1, and 2. This is 1, 2, 3 roots. So you'll write them down as z0, z1, and z2. These are the 3 roots. So I hope you found this video helpful, and that's all I have for now. Thank you for watching.